my backend storage as well. I'm also going to log into the web client because I am pretty sure this is timed out right now. And so we'll be able to see the volumes as they're being created as well and how much data we're writing into it. So let's go ahead. So the first thing we need to be able to do is we want to create our storage class, right? So let's go ahead and see what this looks like. So within here, pretty simple, right? I showed it in the demonstration. We've actually taken a few less parameters, and all we're doing is setting it to a thin-based format. So pretty easy to be able to do. Let's go ahead and we'll create that. All right, so now we have that, and we can make sure that it's there as well. We can say describe our storage class thin disk. So we can see, there we go, it's using the provisioner. That's exactly what we want to be able to use. All right, let me make sure we've got our backend over here. So when this is deployed automatically, we're going to see a cube vol. If you see it while I'm scrolling, feel free to shout out so I don't miss it. Did that pass it? Aha, there it is. Okay. That, I don't know if I can make... Anybody know how to make the vSphere UI bigger? Oh, okay, that's too much. Let's see if we can... All right, we'll see if we can do that. We'll do that here in a minute. So let me go back over here. What we're going to do is we're going to create our volume real quick. So I'm going to look at our PVC, right? So as I'd mentioned, as a developer, I want to create a claim, right? So the claim is going to be referencing that storage class that we had just created. And I'm essentially saying that I want a volume. I want to have a read-write-once capability. I'm going to take it from that thin disk storage class that I just created, and I want it 8 gigs, right? Pretty simple. Let's see, here's PVC. So we're going to have that go over here. We come back over here, do a little bit of refreshing. We're going to see that we should have a volume. So here's our volume that's been created. As we can see that the naming mechanism is a little bit different too, right? It's very, very hard to decipher what this is because it's just says Kubernetes dynamic PVC and it's got some string of random characters behind it, right? So that's all going to be mapped to the persistent volume object in itself. So let's go back over here and let's start writing some data, right? So I want to look at the Postgres deployment here. So this is our deployment, right? We're going to be doing one replica. It's going to be using the Postgres 9.6 image. There's our environment. So if you care what my passwords are everywhere, there it is. We're going to map it to the container port 5432, but the volume mounts is what we care about. So we look at here, varlib Postgres SQL. It's where all the data is written. That's what we want to do, and we're going to put some arbitrary name to it. We're just going to call it PG storage. PG storage is going to map down to our volumes here at the end of this YAML file here. And then what this is saying, it's going to use the persistent volume claim that we had just created too. So let's go ahead and we'll just do kubectl create -f PKS Postgres deploy. So we can see that that's going. I'm going to watch the process here. We need to kubectl get our pods. We're going to say watch kubectl describe pod, and we want to use this pod right here. And we'll be able to see some stuff here at the, let me see if I can, oh, watch isn't going to work very well, so we'll just describe it and we'll just have to look at it a few times here since the text is too big. So we can see that down here we've got the volume, it's set up, it's mounted, it's attached, the container's created, it's started. We come back into here for our vSphere web client, and we should see some data being written to the disk. It's going to be a little bit bigger than 0K now. So there we go. And if we switch back to our not there. We can look at the logs, make sure everything is running. So kubectl, say logs. So we can see that the startup script is ran, it's already started populating, created the first database, and then we got everything running there, right? So we can see that, and I'll show you the difference when we kill this, how different the log size is, right? So we can see from here, that's sort of where it starts, and that's where it goes. So what we're gonna do now is we're gonna kill this, and we're gonna say kubectl delete pod. Now I'm going to say kubectl get pods. And when we do this, since we have a deployment, what it's doing is it's actually, it killed that container, but the deployment itself recognized that, and it's creating another one in its place, right? So we can describe pod. We want to look at this one. And we can see that it's been assigned. Probably just give it a few more seconds. We're going to see a mount failure that's going to happen, and then it will mount it in itself. So we can see that it did have a mount failure, but it went ahead and just redid it again, because essentially what it does, if it tries to go too fast, it's going to say that the volume's not available. It's going to do a retry on it, and it goes and it gets it. And we can see that it's up and starting. If I was a smart presenter, I would have shown you that it's actually running on 2 different hosts within inside of PKS as well. So it actually flipped to do a different host. I forgot to show that while the pods are available. So if we go and we say kubectl logs, and we look at the logs for it, we can see that the logs are a lot shorter now, because essentially all it's doing is it's just resuming from the state of where it once was, right? Now, the other thing we can do is not put seller, but we'll put clear. And we will say delete. We're going to delete our deployment. Postgres. So that's going to delete the pod, but it doesn't delete the volume, right? So all it does is just get rid of the, as I said, all it does is just get rid of the pods and everything. So the persistent volume claim that we created is essentially what is the mapping here, right? So we can see that that's still up and running. Now, when I actually delete my persistent volume claim, and we come back over here to the UI, we're going to see that this is going to disappear, right? So that's how it's all mapping back and forth. And we're running, we got about 20 seconds left. But what I'm going to do is just kind of just show you what the stateful set looks like. So if we just did a Postgres stateful set. So with inside of here, let me scroll up just a little bit. We can see that you have to create essentially a headless service, a network service of how you access your stateful set. And so essentially just what port are you going to access it on. We just score 5432, and we want to map that back here into our stateful set within port 5432. We map the same exact name that we had PG port before. But the other difference that I showed in here that you typically don't want to do is kind of go around the persistent volume claim object in itself. And what we're doing is I'm actually creating everything by referencing the storage class right here with inside of the stateful set, right? So don't do that. You can, but typically it's just not best practice approach. With that, I've got like 15 seconds for a question if we have it. If not, you can stick around because we're going to do a demo here showing functions as a service as well. So, all right, well, thank you all for your time. Appreciate it.